Um, cool. Hi everyone again. Yes, this talk is called Project in Machine Learning. As I said in my previous talk, it was going to be a list of projects because I thought, it'd be really nice to have some set projects, but this one took me long enough, and I wanted to do a start to finish thing, and now I've got less time, so yeah. Oh, hopefully I don't run out of battery power. Okay, so right. What I wanted to do is make a Amazon classifier. So what I wanted to do is, in actual fact, this is going to be in the realms of DVDs, in this case movies, because I just wanted to keep it for general to one topic. I could have extended it to every product, I suppose, and seen how the text reflects the star rating in general. But basically what I wanted to do is create some grand classifier for movies, so you could feed it in a movie review, and Wolfram would determine with his classifier what rating you would get. So, in case you're unfamiliar, by the way, this is this is in detail, so I apologize in advance if you're bored. But this is Amazon. You hadn't seen it before, and we have a review, and this is a film, Exodus, which I've not seen, but I can look at the reviews, and basically I want to be able to extract these reviews and use them in the classifier. And this requires us to be able to go across the URL, because I don't know if Amazon have an API. But I just used our function URL fetch to grab all of these reviews. And I wanted a considerable number of reviews as well. So what do I actually need to do? So I need to find the data source. Well, the data source is amazon.com, or .co.uk in this case. I want to fetch the data. When I fetch the data, I want to format it to data which the Wolfram language can read more efficiently. And then I want to create a classifier predict. I'll explain at the end, but predict would have been better, but I used a classifier in this case. And then finally, we just want to analyze the accuracy of this, so we can streamline the classifier a bit to make it a bit more accurate. So first you actually need the products. What I actually used is this is weird. I actually used the import.io API. We partnered with them before, and they're very interesting. They're a very interesting company. But anyway, I got this link of like the top. Several hundred pages of reviews here. We can see there's 867,000 DVDs that I could go through, and I wanted a reasonable number of movies. I can't remember how many I went for in the end, like 1,000 movies or something like that. And we can see there's a URL. First of all, I wanted to extract the movie link. So if I click on this link, it will bring up this page, and then I can extract the reviews from each one. So I use the import.io API, and I've just got it here ready, which has this. Oh, that doesn't delete it. Which has a bunch of URLs. What we can see actually from this URL is that there's page numbers involved. So there's a page 2, and then there's a page 2 here. So if I change the page 2 to a page 3, then it will go to the third page, etc., etc. So I can just crawl as many pages as I like. So in this case, I'm just crawling over the first 10 pages. I think I ended up crawling over like 200, as I said. And I can run this API. And I just run these queries, and there's a little bit more work involved, but basically I've extracted all the movies and the links associated with the movies for, well, in this case, 72 movies. So that's quite nice. I exported to a CSV, and then I imported it directly into the language. So I have this function, this variable rev data, which already has all the reviews in. And just so you can see the format, see it's very text heavy because it's text analysis. I've got the number of reviews associated with that product, and then the page URL. So there are 10 URLs there are 10 reviews per page. So in this case, 230 reviews will have 24 pages. And so I had to create another set of URLs. In this case, it was about 24,000 URLs because there were 24,000 pages that I was going through to get, in this case, 170,000 reviews. So sifting through 23,641 pages takes a little bit of time. So I use this function parallel map to go map across as many kernels as I have access to. And really, you want to map across as many kernels as you have. So I have 8, so I just map across 8. It doesn't matter that you've only got 4 kernels because you're actually down. A lot of the time is spent downloading the page, and then you're doing this function string cases to look basically for the review text. In this case here, the review text. And the star rating, which is this 0 to 9.99. I use the regular expression. You could use it when you use string cases, you can use regular expressions or Wolfram language string cases, or I don't know what we call it, patterns or something like that is what we call them. But I quite like regular expressions, so you can choose. I think you'll find in my code that I interchange depending on how convenient it was. So I grab all this data and I directly export them into .mx files. You can see here that I export to a MX file with the product name followed by the number. You don't have to understand all this, but just so you know actually what's happening. So I made a bunch of MX files. It's a good format for being able to re-import data because it imports as fast as possible, basically. And then I recombine all the MX files into one MX file and then export it. Because the thing is, when you're downloading so many pages of data, there might be some places where there's failure. And if there's failure in your MX file, then it can be a bit of a pain. So I extract that data first, actually. I actually use cases to extract the data. And then I clean the data and I make sure that the head of the second element is a real number, because what we end up having is the review text followed by the star rating as a real number. Okay, so now I've got my 170,000 reviews. That's it, you know. I want to classify it. So we re-import the data because, you know, it takes a while. And then I classify this data. And I'm not going to classify it now because it takes about 50 seconds. So I'm just going to import. I saved my classifier as an MX file. You can save it as a WDX file as well. WDX files have more universal compatibility with other machines, whereas MX files, I think, are limited to your operating system. Don't quote me on that, though. You can test if you want, but I can't remember what the specifics were. So I re-import this classifier. We've got a classify function, which uses the Markov method with 5 classes, 1 to 5 stars, text analysis with 170,000 reviews. So there's a function classifier information to find out certain parts of information of a classifier. So here you can see the class priors, feature names, feature types, training time, etc. So I've used training time just to show you how long it would have taken, how long you would have been sitting here waiting, and it's 60 seconds in this case. And I'm showing you class priors as well to show you basically, it kind of shows you prior to reading a review what kind of percentage weighting is there based on certain reviews. Now I took like the top 200 reviews, and you know, with the top 200 movies or 200 pages of movies, what you would expect is there's a heavy weighting for 5 stars and less for 1 star. So what we can see 72% was 5 and 5% was 1. But I fed all the data in anyway. Now this is a bad thing. I'll explain it to you later. But now we can test the classifier. So I can go, I hated this movie. Let me just make some space. Oh dear. So it's going on with 5 stars. Okay. I hate this movie. Okay. This movie was great. 5 stars. Well, that's surprising. Okay, average movie. Oh, come on. Come on, this is awful. Okay, I pre-made some just in case something bad happened. Okay, right, okay. So, worst film ever, 1. Greatest film of all time, 5. A pretty average film, 3. Okay, so that's okay. But the thing is, when you've got Amazon reviews, you've got a lot more words, so I'm being very loose here. I mean, what we could do is we could go to one of these films, I suppose, and go, let's grab a 2-star review and feed it in here and see what happens. So the 2-star review, it reviewed as a 3-star. I'll grab a 5-star review, and it's a short one. 5 stars, and we'll just give 1 1-star just to see. Okay, maybe not that one. Okay, someone with a bit more words. Okay, 5. Now, okay, so it's not. We want to see the accuracy of this. Don't trust it. I've given you a very small amount of data here. So we want to analyze this data, and to do that, we have this function classify measurements. So first of all, I'm going to sort all the reviews that I have into groups of star rating. So if I have a look at data sorted 1, 1, we can see that this is the 5-star group, and if I go to 2, 1, it's the 1-star group, 3, 1, 4-star, etc., etc. So I've grouped all the data into groups, and basically I want to take a random sample of 1,000 reviews from 1-star, 2-star, 3-star, 4-star, 5-star. So that's what sample the function, the variable sample 1,000 is. And then I want to use this function classify measurements, which takes a set of a test set for your classifier against your classifier. So I've got my classifier, which I called C, against my 5,000 reviews, and it gives me a classifier measurements object. And you can see it used 5,000 examples for the test to see how accurate it is at determining the star ratings on this thing. And yeah, the number of, okay, it even tells me here, the accuracy was, I spoiled it. No, let's pretend that didn't happen. So I can have a look at the properties of this classifier object, and there's various properties which you may or may not be interested in. Well, one of the things that you can see is a confusion matrix plot, which is quite interesting. And this basically tells us what the actual rating was against the predicted rating, where things went wrong. So this can be really interesting to understand where things are going wrong. So 972 examples in this case were correctly predicted as 5 stars when they were 5 stars. Where it went wrong here, 2 examples of 5 stars were miscalculated as 1, 0 5 stars were miscalculated as 2, and so on and so forth. So this area is a bit sparse, but we can see is in this vertical column is that 5 stars seem to be there's a lot of misclassification when it comes to 5 stars. And the reason why is because there's such a larger proportion of 5-star ratings in this classifier. So this is something that you need to be aware of. So we can have a look at the accuracy in general. In our measurements object, we can say, what is the accuracy? In this case, 46.2%. So that means out of all, when it did all of these, and don't remember, there's 1,000 of each review. So it's not like it's weighted with 5 stars. There's 1,000 1 stars, 1,000 2 stars, 3 stars, etc., etc. So it's done a pretty good job, because if it was completely random, then it would be 20% accuracy, right? So we've got some improvement here. And we can see in precision where things go wrong the most. So it says here that 1-star ratings have a 60% accuracy success rate, 2 stars 20, 3 stars 30, 4 stars 22, and 5 stars 97. So it does 5 stars very, very well, but that's because it often misclassifies everything as 5 stars. So first of all, before I go into redesigning our classifier a bit, we want to see what it looks like to how many reviews would we need to get 100% accuracy. I mean, this is ridiculous, of course, because there's always going to be that human error. But let's have a look. So first of all, I need to create classifiers at different. I need to grab different size samples for the classifier. So I've got samples of 10 to 100,000 classifiers. So I make a bunch of classifiers. Oops, I shouldn't run that. But I'll show you what the result was, just in case you misunderstand what I'm saying. So we've got all these classifiers. So this is like 10 with 10 samples. This is with 20 samples, 30 samples, and we go all the way up to 100,000. So we've made all these classifier functions, and we want to determine the accuracy based on the sample, the test set that we had before. So I've already imported it, actually. So now I want to create a bunch of classifier measurements for each of these classifiers. So for each classifier, I want to put that 5,000 samples into the classifier measurements function and see how well the overall accuracy is. So this takes, I don't think it takes too long. Not nearly as long as the other thing. Does. Okay, it's finished. And basically, we're just going to map on the classifier measurement function the accuracy. So we want to see the accuracy from 0 to 100,000, and we can see that. Well, I'll just draw the plot so it's easier to understand. I should have put axes or something like that. But on the y-axis is the number of reviews that we use for the classifier. And then on the x-axis is the percentage accuracy. And as we can see, that the accuracy goes up with the more reviews, the more data that there actually is, which is what we'd expect. But what we want to know is how much data do we really need to extract to get a given percentage accuracy, I suppose. Well, in this case, I've gone ridiculous and I've said 100% accuracy. So I need to do a model fit. And here I'm doing a nonlinear model fit of A exponential of BX. And okay, whatever. I don't have time to look at that. But let's. I think hopefully, if I plot it, it will look fine. Yep. So I plotted my fitted model, which is 246 e to the 14.8x, and we can see how well it fits. It's not amazing. I'm pretty sure that that's wrong. Maybe you shouldn't quote me on my statistics here in some way, but. I was guessing on an exponential, and it fits kind of okay. And in this case, how many reviews do I need for 100% accuracy? Well, I grab the model, and I say, well, 1 is for 100%, and I need 6.5 times 10 to the 8 reviews, so that's 653 million reviews, right, that I require for 100% accuracy. Now, why do we care about class priors? Well, I said previously that 72% of the results were essentially 5-star. And how do we mitigate that? Well, what you can do is you can normalize your data and just grab, 10,000 1-star, 10,000 2-star, 10,000 3-star, et cetera, But when your sample size is big enough, you don't have to do that. And we can just say the class priors are equally weighted. So prior to actually doing any classification, we're saying that there's an equal probability that each classifier is a certain, that it's going to be a 1-star to a 2-star, et cetera, So I use class priors to make another thing, and this is very similar to what I did before. And I just quickly test, does 3 stars, best movie, 5 stars, worst movie, come on, 1 star. So it's done a little bit better, maybe. And now I do a parallel map here of the same thing that I did before, so 10 to 100,000 reviews, and I haven't really done any cleaning here because I was a little bit lazy, so there's some errors here because some of the classified numbers don't actually exist anymore, because when the sample size is too small, like 10 reviews, the likelihood of you having because I randomly grabbed the data when it came to the classification, that there may not be a 1-star or 2-star review in the sample size that small. So that happened in one instance here. But don't worry about that. It doesn't matter. I clean the data. So I import the data and I grab my multiple classifiers, and you can see the classifiers that failed are these ones here. And what I'm going to do is I'm going to strip them out because they're not very important anyway because the sample size was so small. So I do the same thing as before. I grab the classifier measurements from 10 to 100,000 reviews, again ignoring these errors. And then I want to figure out what the accuracy is. So the prior's accuracy. No, I need to clean the data first. Here we go. So I do some cleaning of the data, and then I find out what the accuracy actually was from 0 to 100,000. I will put it into a plot for you so that you can see. And we can see that, well, I don't know what we can see now. We can see something very similar to what we saw before. And I'll fit a model like I did before. This time I actually used the find formula function in 10.2 to figure out what formula was best for fitting. And in this case, it said it was b times x to the 5. So I'm going to do nonlinear model fit. And it says 3.4 times by 10 to the 6, x to the 5. And then I'll combine this data. And we'll see this fit looks a lot better. So this is quite nice. And then with my model, actually I'll do it later, so I'll mention it now. So just look at that. I think it looks nice. Sure. Here we are now just grabbing the classifier measurements of the big classifier. So we've got 170,000 reviews, and we're getting the classifier measurements of 5,000 test examples as we did before. And then we just want to find the accuracy. So actually, the maximum accuracy that we have here for 170,000 reviews is 56%, whereas before we had 40-something%. And we can see the confusion matrix plot. Actually, I'll just compare it to the previous one so that it's a bit easier for you to understand. So the one on the left is the confusion matrix plot from not doing class priors, normalizing class priors, and the one on the right is where we've done class priors. So we can see that on this vertical column on the right for 5 stars, it's much better when it comes to misclassification of 5 stars, and therefore we get a more accurate result. So the accuracy is 56%, and the accuracy of the original one was 46%. And then just to prove to you that, is the accuracy of the class priors more than the accuracy of the original, it returns true. So no mistakes have been made here, which is great. So one of the things in this, what you'll see in this list plot is I did not include the maximum value, which had 170,000 reviews, because I wanted to show you, based on my model, how accurate my model actually is. So here, my model for 55% accuracy, actually it was 56. Let's go 56.38%. Requires 193,000 reviews, and the number of reviews that I actually had were 170,000. So it's quite close. And we can see the precision as well. And this is actually quite interesting because we see that 1 star, 70% accurate, 5 stars, 90% accurate, 3 stars, 50, and then it gets a little bit inaccurate with 2s and 4s, and the reason why is because I guess that's probably a bit more harder to read. And so, yeah. Okay, so anyway, so I did 55% accuracy requires 100, this is old data. So we said 193,000 reviews. How many do we require for 100% accuracy? And in this case, we require 3.4 million results as opposed to 480 million or whatever. So okay, anyway, that's that. In conclusion, the mass extraction of data, maybe you didn't find that simple, I found it simple. But it's relatively easy to crawl a website with the Wolfram language. The classifier with no knowledge of how to actually use it is actually reasonably accurate, but if we do some simple, that was a simple optimization there, actually increased the accuracy by 10%. If you try predict, actually, you would get a better result in general because, you get, if something was between 4 and 5 stars, it would be 4 and 3, so maybe the data would be a bit more relevant. 56% is more than the 46%, is more than the 20% that you would have gotten, and then 3.2 million reviews is much less than 805 million reviews that was required. Now, last thing. Tom's talk tomorrow, and I'm not just plugging my boss for extra points, but he's giving a talk about the data science platform at 2:15 in the Dow room, and basically he's going to be showing the classifier in action. So this classifier that I've used is used to generate a report which you'll be able to interact with in the cloud, which is really cool. So I don't have time to show it now, and it was designed to be in that talk tomorrow. So there's more information about how that was done. So, great. Thank you very much for listening.